Yes, Professor Tomori, welcome, welcome.
My pleasure. Sorry for time is a little bit whatever here. I'm just getting ready. I've got the slides,
yes,
and I can now start.
Oh.
So I'm supposed to be looking at the issue of vaccine uptake, especially with the challenges in COVID-19 era.
Thank you.
First of all, to say thank you for this invitation. I'm focusing on COVID, but I'll talk a little bit about other issues in Africa. What you see there is the latest information from WHO office of the waves of COVID vaccine outbreak or pandemic in Africa, showing you we've had 3 waves, each wave, each succeeding wave getting bigger than the one before. And part of the reason, of course, is because we are allowing the virus to be spread. We're not following the non-pharmaceutical interventions, and therefore the virus is spreading amongst us. A lot of our people who don't have any, who are not showing what you call the clinical symptoms become the danger point that spread this virus. And through that contact, we are producing variants that are causing more severe infection each time a wave comes. And you can see from February of when the using started, we had a little wave which peaked at about 20,000. The second wave, we had a little low, then the second wave came, which went to 30,000. We are now in the third wave, which is hitting the 40,000 mark on a daily basis at the highest point. And on the right, you see the countries that are showing, it's not particularly showing there, but the countries are showing with total of Africa is about 5 million cases. South Africa is the one that is giving us the largest number. Other countries in West Africa are also showing this. And I'm going straight into the issue of vaccines, so that because we all know, we can get all the information about the COVID situation in Africa. Vaccine production in Africa has been a major problem. We have been far behind in every situation, partly because, not really because vaccine production is that difficult. We have been involved in many things that are more difficult, but it takes a little bit of persistence, a little bit of sustainability, a little bit of commitment on the side of the manufacturer and the government. In Africa, we use virtually all the vaccine we use in Africa is imported. That map is just showing you, as complicated as it is, what it takes to make a vaccine, starting with the starting materials. You need high level of scientific development in terms of nowadays, to be able to get your RNA and split the virus into its component parts and use those parts, either the RNA or the DNA, to make up your vaccine. And in the process, you then go into the whole composing the vaccine itself from the different little bits of the virus that you have. And there are various ways of making vaccines, from inactivated vaccine to using the whole vaccine and attenuating it, so the whole virus and attenuating it, or as now it's been done, just pick a little portion of the virus, like the spike, for example, for COVID, and then manipulating that in such a way that you can get the RNA into the body sees it as something to react to produce antibodies against, that when the real virus comes, because the first point of contact between the virus and the cell is the spike. So the body will have produced antibody against that and then make it possible. But there are different stages of vaccine production, apart from the fact that there's also the issue of the packaging, and there are many aspects of it. Like if you know, the petroleum industry has much to do with vaccine production. Very few people realize that, because even the syringes we are using, all the pipettes that we're using in our research work all come as part of the petroleum industry. And so many other people get involved: transportation, shipping, the cold chain that is prepared to get the vaccines in place. All these are factors which we have to address at a different level in the African region. And here I've shown some of the approaches that this in the vaccine production, in which some they call what you call the backward integration, in which you start from the easiest part. You have a partner who produces the vaccine for you in bulk, and they ship it to you in bulk, and then you can then begin to package and put into little bids for distribution to people. And with that, you can then, starting from that point, you can actually graduate to the point that you begin to formulate and fill your own vaccine. And then finally, get up to the point which I shown at the earlier part, get involved with the research activities of the viruses themselves and the antigen production. Or you can start straight away from your antigen production and then go into the other side. But for most African region, countries in the Africa region, our best approach would have been to start from the fill and finish, have a partner who is already well-known, WHO accredited, that produces vaccine, and then you partner with them, and over a period of time, you get to what you call the technology transfer, and then we begin to produce vaccine at different places. I've shown on this graph what the coronavirus, particularly the market size, is projected to reach about 75 billion by the end of this year. And you see in the under the prominent vendors, which is the middle, on the middle of the slide, you find all of the companies that are involved with vaccine production. Unfortunately, you not find any African every company or country that is involved. But even as we're talking, on the other side, to your extreme right, you will find the upcoming vaccine producers. Again, we don't have any African country that is involved in that. So what we're saying is that we are purely consumers, and that has its constraints over the uptake of the vaccines, because you have no control about your supply. Then you are at the mercy of whoever when they supply, and you are what you call the market prices factors come into play. And if you don't have the money, then you are really in trouble. And so look at the situation, the current situation of African manufacturers. For human vaccines, there are 5 countries in Africa that are currently involved in I'm putting this slide because I made it for my Nigerian population, but my country is missing, just like Kenya is missing, as you notice on this side. For the human vaccine production, you have South Africa producing, Ethiopia, Egypt, Tunisia, and Senegal. Some of them producing different kinds of vaccines. South Africa producing some of the EPI vaccines. Senegal is producing the yellow fever vaccine. Ethiopia is looking at the anti-rabies vaccine. Egypt and Tunisia are working with the pneumococcal vaccines and the BCG vaccines. On the right, you see a little bit better in the African region, where you are talking of animal vaccines. We're not doing much better there. Kenya is here. Nigeria is also here, at least with the production of animal vaccines, as in addition to some of the other countries, which you notice, like Cameroon is also producing, and a few other more countries. So that's almost you find with production in Africa. But then it's so, the African production is so minute. It's of little contribution to the global production. I've gone into a little bit of details of what each of the countries are producing. The South Africa at the bottom is producing the meningococcal vaccines and a few others, and it's in joint agreement with his own government. Senegal is producing the yellow fever vaccine, which is WHO pre-qualified, but it's at limited capacities. It is state-owned. Tunisia produces the BCG, again with limited capacity and state-owned. Egypt also has the DTP. It's the same, you can see the same situation that we have. We have limited capacity, and again, it's state-owned. While in Ethiopia, again, currently is not operational, but it is in place. This is the current situation of vaccine production in Africa. At different times, the African Union has met and the leaders have met on the need, what's the way forward for vaccine production in Africa. We had actually thought of the possibility through the African Vaccine Manufacturers Initiative to have regional hubs for production of vaccines. In which case, if Senegal is producing yellow fever, then no other country in Africa should produce yellow fever. Then yellow fever becomes a market for the entire African region, and therefore it becomes a sustainable product. If South Africa is producing 1, 2, or 3 others, then the others will not be competing with South Africa to produce those things. But then all of us in Africa would then become, we have that market where we can say, this is where we're going to get our vaccine from. That way there's sustainability. That's way our dependence on other parts of the world are much reduced. I've gone in, there's a lot of opportunity for vaccine production in Africa. Do we have what it takes to do? Yes, we have. There are enough human resources in many African countries. excuse me, there are many human resources in many African countries that now being put to full use because the enabling environment for this African capacity work has not been created by government. And we have tended more to procure, to depend on Gavi and UNICEF rather than develop our own capacity. So we have, if we have the adequate funding, if we have national commitment, and something I call national pride, not a beggar nation, not a country that, for example, forever is dependent on donation price coming from one other country or the other. Even donation to take care of your own children. Many of the African countries have reduced ourselves to such state of, there's in the absence of accountability and transparency in some of our business. These are the factors that we need to address to look at the, as I said, the human capacity is there for Africa to get these things done. Sorry. Now, again, I'll go a little bit into the market to let you know that there is a lot of market, and the market is so big, and it's only left for us to get our acts together in Africa, and they will be in a better position to do that. This is what the vaccine market is looking like. 41.6 billion in 2018 has now doubled, more than doubled by year, you're going to double by year 2026, in which you're going to find different kinds of vaccine you make, recombinant vaccines, conjugate vaccines, subunit vaccines, inactivated and life attenuated. These are different areas of which vaccines that can come up. But then it's the North African people that are taking the greatest size of what it is. They're taking 22. In 2018 alone, they took more than half of the market for vaccine. And they're doing the same thing even right now. Again, I've looked at that. Again, I'm talking a little bit about vaccine market, but it is important for us to know that there's money in it if we only get our acts right. And these are some of the situations showing that by 35 billion in 2020, we moved to 83.5 billion. That's the total vaccine market. And there are different types, depending on human papilloma, inactivated vaccines, hepatitis vaccines, and we can get involved. And there are some other vaccines, for our own sake. There are diseases in Africa which nobody is making vaccines for. It is in our position, for the sake of our people, to get involved in the research and development that will end up with the production of this vaccine. At the bottom, you see that the large share of the market, 38% is in North America, 26% is in Europe, and then India, which you may say is not an African country, but so-called underdeveloped or least developed country. India actually has come in to make a major role in the balance of what is left there. But unfortunately, Africa is not part of the situation. Again, look at the growth of vaccine production by the regions. And we're looking at a situation in which United States, is showing the percentage change. The world, there'll be a growth of about 4.4% regarding vaccine production. And for the European area, it's going to go up by 3.8. In the Middle East and Central Asia, you're looking at about 3.8 development, while the emerging centers in Asia will grow by about 6%, most of it, as I said, in Africa. Part of it is in terms of consumption, and Africa has a chance to become part of that development. Now, there are new vaccines, and they are safer for world use. Because again, we can be part of this preparedness. And let me, again, give some other area where Africa really needs to be quite concerned. That graph shows you the vaccine uptake, projected need of vaccine in the different parts of the world. You're looking at the high-income countries, their need for vaccine by the year 2030 is going to really taper off. But look at our low and middle-income countries, because we have uncontrolled population, we have all these other diseases that are coming, our requirement for vaccines will begin to rise and go out of the roof. And you look at the vaccine doses that we're needing in millions of doses. We'll be projected by 2030 to be living at least 1 billion of doses of vaccines. And if we don't take time, all of this will be produced by those outside. It is time for us in Africa to get ourselves involved over the next 10 years, to be part of this large, massive production of vaccines that would be needed, and that we are not just consumers, but also. COVID vaccine is what I'm going to talk about, showing strength there. And for Currently, the COVID vaccine update, there are 24 vaccines which are approved by used by at least one national regulatory authority. There are 187 billion doses which have been secured globally, either bought for or not paid for, and which hopefully to be delivered before the end of 2022. The COVID vaccine, which is what the African region is looking at, is going to get about 20% of its supply by the end of year 2022. WHO has listed 7 vaccines, under emergency use operation, and each of those vaccines, depending on which one you're using, will range from about $2 per dose to the $37 per dose. Like the inactivated vaccines from China are costing about $2, while the big Pfizer mRNA vaccines are costing about $37 per dose. And currently, there have been 272 million doses have been shipped by COVAX to 141 countries all over the world. That is the situation with vaccine. I'm putting that in a better perspective. The COVID vaccine market analysis for 2020 is about 59 billion. These figures will keep changing depending on, because nobody can actually predict what COVID is going to be like. Is it going to peter out? Is it going to escalate? Are we going to have more variants? Are we going to have more? So whatever figures we have here are just estimates. Some of the areas, each of the vaccines, the different vaccines, from AstraZeneca, Pfizer, cancer, all of the other ones, some of them are not here, which are all coming up, which the number of doses are expected are shown to the extreme right. We're showing the price range in the middle of the slide to show you per dose how much we'll be paying. So we're talking of a lot of money in the life of our people. This is showing you the 43 manufacturers, in 14 countries. Look at the map to your left. You find that a lot of the countries that are producing are in the Asian countries, part of Asia. Most of it is in India. You see one little dot for Africa at the corner. Part of South America are making production. You'll notice that Europe itself is not even that involved in vaccine production. Most of it has now shifted to part of Asia. Asia and those other parts. How come we got left out in the African region? Many of these countries in the Asian region got independence at the same time as we also in Africa. I think we need to examine ourselves, and this kind of opportunity, I'm hoping that your committee in our different countries in Africa, we all get together and get to talk to our leaders and talk to ourselves and see something is happening, something is wrong somewhere. Why is so much of emphasis vaccine production? How did you manage to shift to Asia? Many of whom got independence at the same time as we did, and yet Africa has not made the right map. I've done this map before just to show you. This is another one showing when the issue of COVID vaccines started, many countries in Europe and others committed and were buying up all the vaccines. And then instead of doing what we need to do, these proactive countries were buying up vaccines. At that time, they didn't even know which of the vaccines was going to work. So what we regarded as hoarding was not really hoarding, was actually preparedness. So they had Moderna, they had Pfizer, they had AstraZeneca. At the time all this started, nobody knew which one was going to work. So to be on the safe side, they bought, shares in each of these, or amounts of doses in each of those ones. Just in case if A or B, if they do not work, then at least they're protecting their people. I think this is one point I want us in Africa to look at. Don't condemn those European projects, what you call hoarding. I don't call it hoarding. These are people who care about their people, who are proactive, who were not sure whether ABC vaccine was going to work, and therefore they bought up medicine. Well, if they should release it now, that's a different story. But then you also had the opportunity. We also had the opportunity to buy up, but what did we use our money for? That's the matter. But these are the issues that we have, and I think we need to look at that. Now I'm going to talk about the issue of some of the problems we have, why we're not, two things are occurring. We don't even have the vaccine, so it's difficult to talk about vaccine when you don't have enough. It is when you have enough that you can talk about people not receiving. That graph, which came up from one of our colleagues, was showing that I think African CDC and a few other people got together and tried to find out what is the attitude, the hesitancy against COVID vaccine in general vaccine in general, and especially COVID vaccine. You will find, look at the one for Nigeria, for example, at the top. These are various estimates that are formed by different groups. So in some cases you find hesitancy in some areas, was ranged from about 0 to almost about 40%. Again, depending on which group of people you're talking to. You're talking to health workers, you're talking to people in the rural areas, you're talking to urban centers. And so you not be surprised about this kind of hesitancy percentages that estimates are getting. Kenya also almost like what's happened in Nigeria. I think Nigerians and Kenyans almost behave the same way. We're quite different from Ethiopia, Niger, and Tunisia, where you don't find too much, there's a consistency. When you look at South Africa, you look at Malawi, a few others, we tend to behave the same way in that situation, in terms of different groups of people have different rates of hesitancy. But these are all factors. Now, what are the things you're showing for hesitancy and the uptake? Globally, it is not an African problem alone. There has been a rise in general vaccine hesitancy, and especially to world COVID vaccine in general. In Africa, we have different reasons and different things that are driving hesitancy. Let's look at the first point. There's widespread concern about safety, about side effects, and effectiveness. Now, why not? A lot of these vaccines the clinical trials took place outside of Africa. Thank God for South Africa and maybe Tunisia. Thank God again, especially for South Africa. Remember the clinical trial they did there was what showed them that the AstraZeneca was not going to be effective against their strain. But we sit down in many African countries, waiting for, quote, guinea pigs in other parts of the world to be tested about the clinical trials. Then we want to consume those things. And when those come, we say, oh, no, we don't trust you. You have the opportunity to get involved in clinical trials. We will not get involved in clinical trials. And that's the reason why it's part of the thing. So they bring this thing up from past experience and say, oh, no, we don't trust this vaccine. But it's so ridiculous because 99% of whatever we use come from outside. Virtually every drug you use, your anti-malaria, your anti-diabetes, whatever, they come in from all over this called Western world. And yet, if they didn't use it to kill you, if they are safe, why should COVID vaccine not be safe? But again, these are some of the issues. But of course, you have to look at, people also think that the COVID vaccine are much less safer than and less effective for reasons, because you remember that story about the fact that, oh, they produced this in too fast. It took such a quick time, how could they do it? These same people have not produced vaccine for malaria. They have not produced vaccine for HIV. How come they made this one now? They want to use it to kill us. It's so ridiculous when people make that kind of thing. Simple analysis would show you that COVID vaccine was not produced that fast. The foundation for COVID vaccine was laid with MERS-CoV, which is the Middle Eastern SARS-CoV, that with also the SARS-CoV that came up in this, they actually got vaccines for those diseases. But because they didn't have an epidemic, then everybody forgot about them. So when SARS-CoV-2 came, it was just starting off from where they left off. So if you are going to look at the time of production of the vaccine, you have to take it from the time they used in producing the MERS-CoV. And so it was not produced too fast, even if it was produced too fast, assuming it was. All of the safety measures were not compromised. The whole process that takes the length in vaccine production is not the clinical trials. It is particularly the system of the production. And therefore, I think we need to, again, educate our people when we have the right information, tell our people that these things were not produced. But then as quickly as possible without the compromising on the safety. But then you also remember, let's also be frank that in some of when we saw what happened in South Africa, showed that the ineffectiveness of the AstraZeneca, and also in some side effect that we found in Europe, that led to suspension of the rollout of that particular vaccine, not only in European countries, but also in Africa. You remember the United States temporarily suspended Johnson & Johnson to evaluate reports of blood clotting. Again, these are factors which were not, we didn't miss those factors, and that also affected our attitude to those vaccines. The access to social media now has facilitated the spread of good information, bad information, misinformation, and incorrect information, and also conspiracy theories. And all these factors, if you do not counter them as soon as they come out, they stay around and they become the fact for the people. And like I was telling some of our government officials, provide all the facts that you have. Do not leave any gap. Any gap you leave, there's never a vacuum in the world. Any gap we leave will be filled by misinformation, which travels faster than the correct information. And therefore, the governments, to all scientists, to all of us, get out all the information to the people. Let them know what it is. Where we cannot have, where we don't have an answer, let's be honest enough to say we don't have an answer, and then move on. And so, of course, one of the issues is that we don't trust our government. Even when they're doing something good, we don't believe in what they're doing. It's not only in Nigeria. I'm sure it's also the same thing in virtually every African countries, because we have government leaders and leaders who do not really care about their people, who are there for themselves and not for the people. And therefore, they deceive us, especially during the election campaign, deceive us so much that we've never learned to trust them. So even when they're doing something good, it's difficult to trust them. And then you have religious beliefs. Again, their leaders at different levels of life, political, religious. Your church pastor says everything can be healed by God, but he also forgets to tell you that Jesus Christ, when he was healing people, at the time, he bent down, took the soil, and rubbed it into somebody's eyes. Things of that nature. Some people touch his eyes, not just by prayer alone, prayer and work, but a lot of religious leaders, for their own sake and for their own greed, would not use science. Science is not contrary to religion. I mean, science confirms religion. And I think we shouldn't be ignorant of either. So close to 90% of individuals in my country, in Niger and Liberia, said that prayer was more effective than the vaccine. And that's what you find. You find that is something. And then the perception of magnitude of the threat of the disease. You remember when the whole story came about that COVID came and was killing people a lot in Europe and America, and Bill Gates and others said we're going to have dead bodies all over the place. But at that time, both Bill Gates and others were talking out of ignorance because none of us knew about what the disease is. But then as time goes on, we're now beginning to understand why it is. This disease is killing more elderly people who have comorbidities, which is not the situation in terms of population distribution in Africa, where we have a larger proportion of people under 40 who normally, mostly now, except until the variants started coming, who mostly now come in with asymptomatic infection and are busy spreading to the older people. And so that was the reverse. So when we did see dead bodies, then we thought, oh no, this is not as important. But then COVID is more than death. There are also other things that COVID does. And because we're not testing properly, we didn't really know the burden of the disease. So people didn't see anybody dying. They didn't see anybody sick. There was no problem. When we introduced the non-pharmaceutical interventions, nobody took us seriously. I think one of the other things I think a lot of our African governments all do is the fact that they believe that they are the ones who are controlling diseases. It's not. It is the people who control disease. It's the way the people behave. It is the action of the people that determines whether a disease spreads or doesn't spread. I keep talking about the issue when you mention mobile phone. Your phone is not mobile. If you put it on that table, that's where it remains. You are responsible for making that phone mobile. And therefore, we are also responsible for taking coronavirus and making it mobile and spreading it among the people. But if we do the non-pharmaceutical intervention, we can stop it in its track. These are messages I think we need to get to our people in our different capacities and let the government take off its shoulder the fact that she's the one controlling disease in the country. It is the people who are controlling the disease. And if you talk to them the right way, they will be able to get that done. So mistrust of vaccines, I already mentioned that, of vaccines that are developed in Western countries. We've had situations where they have done clinical trials in different parts of Africa, which have not been done ethically. I know of the one in Nigeria where they came to test Tryptophan during the meningitis epidemic by Pfizer. So in fact, in Nigeria, they actually said Pfizer came to test the vaccine, and that's why it killed a lot of people in Kano at that time, and confusing the bacteria, the drug with the vaccine. But since the name Pfizer was associated with it, nobody in Nigeria wanted to take the Pfizer vaccine because of past experience with them. And then, as I said, however, I think the important thing to know is that the perception about vaccines will change. As we found, just like, remember, we had a time in Nigeria where there was a big boycott of polio vaccine. But gradually, by getting to the people, involving the community, involving the leaders, getting the right message to the right people, not giving your message on the national TV in Nairobi or in Lagos, but getting that to the whatever method you have to get to the people in the community, then we're able to get political leaders, religious leaders convinced to get to our people. So how do you communicate with your people? It's only one way we can change the perception about the vaccines. We need to improve on the slow vaccine rollout supply, which is what I have a slide which is going to show you some of the problems that we're having. Because if you tell me, come out the vaccine, and then you don't have the vaccine to give me for the next 1 week, 2 weeks, 3 weeks, and then I lose interest in it. Even when you bring the vaccine next time, I'm not going to follow you. So if with increasing vaccine supply in Africa and expansion of our communication campaigns, I think we're going to get positive changes. I put this as one of the last slides about, is it hesitancy or is it unavailability? If you look at the different regions, the doses that are administered, percent of supply, and let's take them one by one. Globally, there are about 6.4 billion doses which have been administered. The supply is there, but the number of people who are fully vaccinated globally is 2.4 billion, making that they have covered about 30.4% of the population have been fully covered with the vaccine. And then look at Africa. In Africa, we've only received about 124 million doses, of which represent about 79, almost 80% of the supply have been administered. That is, 80% of the 124 have been administered. We now have about 50.2 fully vaccinated people in Africa, which only represent 2% of our population, of the entire population have been covered. And then take this story down the line as we descend. South Africa is probably doing very much better than most African countries. They have overused their supply more than the supply did. I think the reason for that is that in many of the containers of the vaccine, the vials, they will tell you they have 10 doses, but sometimes they have more than 10 doses, sometimes up to 12 or 13 doses. And therefore, so when you see a large percentage of supply administered in various countries, that is the reason for that large number. South Africa has used virtually everything they got, and vaccinated about 7.3 million of their people, but that only represents 12% of the population. Rwanda has 7.9% of the population, fully covered. Great Kenya, you have only 1.6%. I think your number may have moved out, at least the last figure I had. So out of the 3.9 million doses you have, which represent only about 67% of, which you have administered. The fully vaccinated people in Kenya is about 2.8 million, which represents only about 1.6% of them. And that goes down the situation. Ghana has 1.3%. Ethiopia has even much, much less than that, with only 2.5 million doses available and having fully vaccinated 0.4 million people. The number is almost negligible, the number of people that are fully covered. At the bottom, see, Nigeria is showing you that we too are upside down. We have we have used virtually everything they gave us, but that has only been able to cover about 1.7 million people, and only 8% of our people are fully covered. At the bottom, you see the United Kingdom. Is the difference between the African countries and us. They had 92 million doses. I'm not too sure exactly what it is, but they've been able to fully cover 44 million people, which represents 60% of their population. And so that's the conclusion. We have a chance. These are the problems we have. You and I have a role to play in getting that information to our government, to our people, to our community, to the private sector. So let's all work together. Africa has the talent, has the individuals. It is that enabling environment for us to make use of this talent. The people who go out and want to go to the diaspora, they are not better than those who are remaining. But when they get there, they excel because the enabling environment for them to bring out the best of their excellence was there. In Africa, the environment depresses your excellence. The environment reduces your excellence. The environment makes you an expert into a novice. These are areas you and I have to get involved in. Thank you very much for the opportunity. Over.
I know, yeah. Yes, he's there in this session, yes.
Thank you, Wallace. I finished.
Thank you very much, Professor Tomori. So, ladies and gentlemen, you've listened to him. So, who is Professor Tomori? Professor Oyewale Tomori is a past president of the Nigerian Academy of Science with experience in virology, disease prevention and control. He was at the University of Ibadan from 1971 to 1994. He later served as the pioneer vice chancellor of the Redeemers University in Nigeria, that is from 2004 to 2011. From 1994 to 2004, he was a virologist of the World Health Organization's Africa region, establishing the African Regional Polio Laboratory Network. And in 1981, he was recognized by the US Centers for Disease Control and Prevention for contributions to Lassa fever research. In 2002, he received the Nigerian National Order of Merit, the country's highest award of academic and intellectual attainment and national development. He has authored more than 160 scientific publications. Dr. Tomori has served on and also continues to serve on numerous advisory committees, including, for example, nationally, the chair of Lassa Fever Steering Committee, the National Laboratory Technical Working Group, expert working groups on polio eradication and routine immunization, and others. And internationally, he is part of the WHO SAGE, WHO Africa Regional Polio Certification Committee, WHO Group of Experts of Yellow Fever Disease, Chairman, WHO Yellow Fever Emergency Committee on International Health Regulations, Gavi Board, Vice Chair of US National Academy of Medicine Global Health Risk Framework Commission, and World Bank Interagency Working Group on Financing Preparedness and Response. Regarding COVID-19, he has served as a laboratory planning and quality monitoring advisor to the WHO Afro region, region director, and is the chairman of the Ministerial Expert Advisory Committee on COVID-19 Health Sector Response. He is an international member of the US National Academy of Medicine and currently chair, Board of Biovaccines, Nigeria Limited. He is a member of the Global Viral Project Leadership Board and a senior fellow, Scowcroft Institute of the Bush School of Government and Public Service, Texas A&M University. That was the gentleman that you've just listened to. So, Professor Tomori, we are very grateful for your insights into vaccines generally and more specifically about vaccines in Kenya, I mean in Africa and in the world. And I'm very privileged to actually open the floor now for people to ask questions. I know in our room here, we have quite a number of people. I think we probably have more people in this room than the other room. And therefore there must be a very big interest regarding COVID-19. And so we'll take maybe another few minutes because we need to move on, asking questions. Who has a question, the first one? First question to Professor Tomori. Professor Walter Jaoko, please go ahead and ask your question.
Thank you very much, Prof, for the presentation. Really excellent presentation. I'm just concerned about the vaccine hesitance in Africa, because a lot of what you said, the social media propaganda, actually comes from the West, but the consumers are in Africa. Do you have any thoughts on how we can be able to counter the propaganda against vaccines that is really influencing our young people not to be vaccinated? Thanks.
Should I answer or take all the questions?
Well, there's no other question at the moment, nobody with the hand, so go ahead.
Thank you, my friend, Walter. You know, part of the problem is that I use the word we are consumers without thinking. And when all this information comes from outside, we just suck it in without really evaluating. Somebody comes in and says, I'm a chiropractor and I've been practicing for the last 20 years. I'm going to talk to you about vaccine. What does a chiropractor know about vaccine? We don't look into all those things. When a pastor in your church tells you, listen about vaccine, what does he know about microbiology? What does he know about immunology? Yet, will you, if a carpenter comes to you and says he wants to repair your car, will you allow him? So why do we allow novices, people who don't know anything about what they're doing, to talk about those things for us? So it's left for you and I, who know the fact. Anytime, it is a frontal attack to all those rumors when they come in. We go after them with the facts. We don't let them, allow them to wait for a day or two. And I do that on the WhatsApp group I belong to. Whenever any of these stories come, I always tell our people, don't send this thing to me if you don't have any information about it. If you're asking me a question, ask, is this true? Then we will go about, but then I read anything about all this that come from all those, I go back to the records myself. I spend my time and then get out the information. And the little knowledge I have, I counter it with them and say that, and give examples, local examples of what things are. And I think that's the only way. We have to frontally attack all these sorry to use the word, dubious people, conspiracy theory people. And it is for us, so we have the role to play, to be up to date ourselves about the facts and information, and counter any of those rumors with the facts and information. Over.
Thank you very much. I can see Professor Kwanashe's hand is up. Professor Helen Kwanashe, please ask the question.
Okay, thank you very much, Professor Tomori. This question is making me sound like a broken record. With these discrepancies between the developed world and us, what is going to happen regarding the spread of the virus? If they are all vaccinated there and we are not vaccinated, is it going to be contained at all? What moves are being taken to make sure that everybody is carried along? Thank you.
Thank you very much. Our colleagues and friends in Europe and others who were vaccinating themselves and forgetting, they are forgetting that they are not in isolation. The world is one big place. And we haven't seen the evidence now. The variants in India, the variants in Asia is the one overcoming the vaccines, all the people that are vaccinated. So I hope they will learn from what is happening. Israel came up with, was supposed to have done very well. Britain itself wanted to open up. And then people came in from other parts. There's only so much you can stop you from coming to your place. So long as you focus on your own people, well, to a point, they have a right to defend their people, but at the same time, they must think globally. And the only way to do that, two approaches. One, they must get this vaccine as quickly around the world as possible so that we don't have it spreading all over. And those of us who are on the other side too, we must not just wait passively. Perhaps we're too late for COVID, but I want us to begin to think ahead and say for the future, the next epidemic, we don't know where it's coming from. Are we going to be prepared? Or are we going to be beggars again? These are two sides. So the guys who are ensuring that they vaccinate their people and think they are safe, I think they are now seeing that they are not safe. So the world is one. So they get the message to them. I hope they are learning. And for those of us sitting here passively, waiting for donation, time for us to act and not become beggars. Over.
Professor Tomori, there's one more question that I've seen on the chart there. It says a lot of vaccine hesitancy has been noted among healthcare workers. Are there any strategies that you can use to counter this? If you answer that, then we may close and move on to the next stage.
Thank you very much. I think it's unfortunate that health workers, who should know better, are the ones that are showing hesitancy. But it also shows, it's nothing new. You have professors in university who can't profess. You have doctors who are quacks. You have health workers who are quacks. Well, we need to identify those people and look for them and educate them as we're educating the people. I think it's an assumption to assume that because I'm a health worker, I know about health. We need to properly check our health workers and get that information that is to each and every one of them. Over, sir.
Thank you very much. In interest of time, I think we're going to stop there. And again, Professor Tomori, thank you very much for a very stimulating discussion, a very stimulating presentation.
Professor Bulimo?
Yeah.
Can we allow Andrew Walubo to ask a question? I saw his hand up, please.
I did
I thought the time was gone, but I can ask because I think it is.
Okay, Professor Walubo, please. One last one, yes.
Thank you very much, and thank you for the presentation. I will say I'm one of the health workers. The point here is that, and of course being a clinical pharmacologist, is that the preaching, as you said, the preaching should be very, very not denial on the other side, that there is no drug which has no side effect. We should accept that and then start convincing people that still there is that importance for doing this. But my point or my question is this. We know that COVID vaccine has been rushed, as people put it. Despite all the explanations, people know this one was produced faster than any other. No, so there has not been enough. These are the reasons behind that hesitance, which is some of them. Now, on me as a health worker, a clinical pharmacologist who's looking at issues of making those who are especially educated to see that actually we are doing things in a very, good, how to say, scientific way. Here is a disease, COVID, which immunopathology is responsible for its pathogenesis, the worst stage, overstimulation of the immune system. And we know that the vaccine is also doing the same mechanism, producing or stimulating the immune system against COVID. And probably those who happen to get worse, what is part of the cause of the problem that is causing side effects, causing the others even to die. What I would have looked at is that, what I'm asking is that, isn't there a way by which we could at least have biomarkers, immunological biomarkers, to identify patients who are responding or over-immune stimulated, who are likely to get worse or drive into a COVID picture? I think that's where that could lay that when you vaccinate people, there are people you say, if you get this, we need to measure this marker, and then you could be able to intervene because you are stimulating the immune system in the same way the virus does. And in that way, we don't know what makes the immune system stop. It's just because the vaccine, how isn't there some people are likely to over-respond? But here is a case whereby people are immunized and then they are told just to go to elsewhere, people who don't know probably the pathophysiology of the vaccine. So I'm looking at people who have developed biomarkers, but what are we doing here to see that we monitor patients who are responding in certain ways so that we ensure that still, even with vaccination, we are also able to follow up you in order to ensure safe outcome. Thank you. So a biomarker, please.
Thank you, Andrew. I mean, those are the points, being proactive. Those are the points that those of us who are in the forefront, the health worker in the forefront, the clinical pharmacologists, the clinicians, have to go together. I'm sure if you provide them, if you write a proposal to describe what you're saying and look for funding, you're going to get the funding. We don't have to wait for Europe to do that. And even if they do it, doesn't mean that it's going to work exactly. So you raise a very important point. You have identified a subject that needs to be looked into. Why don't you get together with your colleagues and then write a proposal and look for funding to do this one? That's number one. The other point you raised about health workers, I think I should have made a point that the health workers are the frontline defenders of this. We must protect them first and foremost. I mean, we must get them to have all the PPE and everything that they require. If they don't see any of their people dying, of course, they will not lose, there will not be hesitancy on their own side. So, Brother Andrew, you're speaking in my mind. We need to get together with the group. These biomarkers you're talking about, what are we doing? What are you doing? Get the group together in Nairobi. Let's make it an African thing, and let's work together and get the multinational, multi-center study for this time you have seen. But bear in mind that in other vaccines, because we have this COVID right on our head now, that's why all these issues are coming. But the other vaccines, people get the vaccine and you assume they get this thing until maybe an epidemic comes and it shows whether we don't have it or not. So this is a different ball game with COVID vaccine compared to, say, measles or yellow fever, which have been around for a long time. And again, let me also, you raised one point, I think we need to say that on, you use the word rushed. I don't think the thing was rushed. Let's face it. Because if it's coming from you, then there's a bit of a problem also. And the explanation behind it is not rushing. The time that's taken to do the clinical trials is the same time they use for other things. The only advantage we have is the fact that There's an ongoing epidemic. Therefore, you can do your efficacy study as quickly as possible because of an epidemic. Take yellow fever or the other, take measles. You won't know until an epidemic occurs. And you don't want a disease to keep occurring because you want to do efficacy studies. We did that in Ebola in Guinea. They couldn't finish the efficacy studies because the epidemic went out, petered out. So different circumstances, please, as scientists, let's look at it on that light. You know, it was not rushed. The foundation had already been laid. It's like in your own house, you do your electrical points in your house, and you have various sockets in the house. Then you plug a fan here, you plug the TV here. The foundation is already there. It is not the day you plug that thing that you started making the electricity in your house. So it's the same thing with all this one. The foundation for the vaccine was made with mask up, was made with sack up. Thank you, sir.
Thank you very much.
Okay, thank you, both of you. I think we are going to move on to the next presenter. Our next presenter is going to be Professor Brian Harvey. Brian is currently affiliated to the Center of Excellence in Pharmaceutical Science, School of Pharmacy, Northwest University, Potchefstroom, South Africa. Did I pronounce that one well? I don't understand it. But anyway, Potchefstroom and South Africa. South African MRC unit on risk and resilience in mental disorders at the University of Cape Town. He holds a degree, he holds degrees in pharmacy and pharmacology with an MSc and PhD in neurosciences and psychopharmacology. Prior to entering academia, Brian spent his formative years in the neuroscience division of Eli Lilly, South Africa, where he developed a keen interest in biological psychiatry. It was here that he was first introduced to behavioral psychopharmacology and using translational animal models as a research platform in drug development. This remains the focus of his research to this day. Upon re-entering academia, Brian turned his attention to learning more of the underpinnings of psychiatric illness, especially novel drug discovery. His expertise is in the development and application of translational animal models of major depression, schizophrenia, post-traumatic stress disorder, obsessive compulsive disorder, and addiction using rodent and zebrafish models. Ladies and gentlemen, let us welcome Brian to the stage. Welcome.
Thank you very much, Wallace. I appreciate the kind words, and from my side, thank you very much for the invitation from the organizing committee to present here today. It's been a sort of a highlight for my year because of the constraints of COVID and the travel and so forth, and of course all the restrictions on congresses and so forth. So this is really exciting for me, and especially to present to my African colleagues. But I'm going to just share my screen here. Let's see. See, it's progressing to another screen. Right, so today, everyone see my screen? Is it functional?
Yes, yes, you can see it.
Can you put on video show or not? Screen.
I think I'm not getting a.
Put it on the slideshow.
I'm trying to find that now. My mouse has just disappeared. Hang on. I'm trying to think here now. jump to the screen. Okay, here we go. So where is this? Here you are. Now it's there.
Okay, now stop sharing. Go. Stop sharing. Stop sharing. Bottom. There. Okay, now you say share again. She's. Okay, now we got this. I want to make a preview again.
Under the screen.
Preview.
No, here it is. Come here.
Yeah. From my screen. Do you want to come to my screen?
Here it is. Okay, now.
The preview. Slideshow. Yeah. Now you say screen sharing. Ratio zoom. Okay, now this drag the zoom screen to the other screen. Say screen, share screen. And then you share. There we go. Right, you're ready. You can go.
Can I take my video off? All right, sorry, ladies and gents, some technical issues here with, I've got these screens, sometimes don't allow me to connect with what I'm going to present with. So can I just go like this?
Mouse back here. No, I think.
Can you see it? It is now on. We are sharing.
All right, so can I go back to the... Okay, there we go. Thanks to my colleague for his expert advice. Right, so today I'm going to be presenting on understanding the neuropsychiatric manifestations COVID-associated illness, especially the psychiatric manifestations, and then try and look at the issues around maybe repurposing old and existing drugs. And it was very interesting to see Michael's presentation earlier on, where he covered about the idea of trying to, target and develop older drugs. And it's also, very interesting as well that he covered things such as around the central nervous system drugs. And, I think there's been a lot of controversy around the actual value of these drugs. There was an initial hype around that, and take notice of his of the observations of phospholipidosis and how this may actually blur the lines somewhat. But I think no one can deny there is something going on here. There's a very important manifestation on the brain with COVID, which we hope to try and address from a psychiatric perspective. Right, so severe acute respiratory syndrome corona 2, or as we know as the SARS-CoV-2, was first identified in Wuhan, China, as we all know, nearly 2 years ago. Now, this virus is what caused the disease, what we've now come known as coronavirus disease of 2019, or known as COVID-19. And as you've heard in the previous presentations, it's associated with enduring and potentially lethal respiratory effects. But it's also become evident, in the last couple of months as well, ongoing research that the virus is a neutrophic virus with a strong affinity for the nervous system. And there's been some study to show that from human cell cultures and post-mortem studies that demonstrate that the virus is capable of neuroinvasion. So bearing that in mind, it's not unusual to take note that patients who have this virus show a high manifestation of psychiatric disease. So let's take a look at that a bit closely regarding COVID-2 and the psychiatric disorders. So, for instance, depression, mania, anxiety, and PTSD, which are probably some of the most prevalent of human psychiatric disorders, is found to can be precipitated. In other words, a new illness can be precipitated in patients with COVID, or it can exacerbate an existing illness. And what's even more startling is the fact that the psychological stress that patients with COVID were undergoing is compounded by the presence of the psychiatric illness, and of course the presence of the virus itself. And the stresses, of course, come from the issues such as loss of income, fearful of the future, illness and loss of a loved one. So these patients are already at psychological risk for developing a psychological order, and then they still have the issue of the virus to contend with as well. So the question is out there at the moment, is there a biological component that is associated with SARS-CoV-2 and the associated psychiatric illnesses that is becoming increasingly more prevalent in the populations? So let's have a look at what SARS-CoV-2 infection has on the inflammatory response. This is more of an abbreviated form that you saw earlier on in Professor Spedding's presentation. So the SARS virus then has a high affinity for binding to the angiotensin converting enzyme type 2 receptor of the human cell, the host cell. And inside the cell, it has two options, which it eventually will target, is either capturing of the viral RNA of the host for replication. And the other thing that's very important, and we've also heard in previous presentations, is that it then infects or influences the mitochondria. But the mitochondria doesn't sit and allow itself to be infected or taken over. It releases a host of different messages known as mitochondrial antiviral signaling, which is then involved in the increased cytokine release into the body. Now, of course, we all know the cytokines. One of the biggest aspects of COVID is the cytokine storm and the overwhelming stimulation of the immune response that this infection gives. But let's have a look at the cascade when you combine it with the stress response, and I think that's what we want to try and show. So you can see on the top right there that stress influences the brain, whether it's a chronic or an acute stress has a different impact on the brain and how the brain manages that stress response. But most importantly, as I noted, SARS virus then captures the ACE2 receptor, decreases its availability and functionality in the central nervous system. And by doing that, it has these two important functions. It suppresses the HPA axis functioning, so you will find decreased signaling from the pituitary gland to the adrenal gland, and there you'll have a decreased release of glucocorticoids and their beneficial effects on inflammation. In other words, you will have an ongoing, recurrent, reverberant inflammatory loop that just persists, and that's where you get the cytokine storm that is not contained. On the other side there, you see in the sympathetic nervous system from the brain, governing your sympathetic activity, again to the peripheral areas, which is also harnessed by the virus, has exactly the same type of implications, but just having a two-prong effect on adrenal function, but now start directly affecting your catecholamines, which together having effects on the peripheral nervous system, the functionality of the nervous system, but also then having various effects on inflammation. So let's now look at that issue of inflammation and see what happens in the brain. So this is very much of an abbreviated form of what may be happening in the brain as far as redox inflammatory cascades are concerned. But let's begin in the bottom left corner over there. We start with the inflammatory cascades, which have been initiated by COVID. So we see the inflammatory mediators. What do? That is things such as interleukins and interferons, which then act on this very critical inflammatory mediator known as NF-kappa beta, which then activates in the inducible form of nitric oxide, which then releases nitric oxide, which has two roles, as we'll come across later on the slide. It goes down towards the cyclic AMP path, which I'll talk about later, or it can penetrate the redox system in the synthesis of peroxynitrite by combining with any production of superoxide in the system. And when these two combine, they are severely neurotoxic, causing lipid peroxidation and cell damage. At the same time, as I mentioned, we have this mitochondrial involvement, and that was something that was also made very strong in Professor Spedding's presentation. So mitochondrial dysfunction is very prominent, especially its dysfunction. It's no longer able to regulate redox pathway, which is one of its primary functions. Especially, you can see there, this production of superoxide is no longer contained by a superoxide dismutase and the glutathione reductase system. And this results in excessive productions of hydroxyl radical, again causing cell damage. And that you can see combines with a peroxynitrite over there on the left-hand side of that figure, causing very severe damage to cells. At the same time, you can see that see if I can use my, you can see this over here, but you can see then this NADPH oxidase, when it is also functional in this redox system, it activates glutamate release. And now we can start seeing transmitters coming into the play. Of course, glutamate being a very pronounced transmitter in the brain involved with a number of functionalities, either being neuro or psycho, but it's also involved in the susceptibility of cells to death and to be targeting by cell toxic molecules. And that's like calcium over there. You can see calcium gets mobilized into the cell. Calcium now activates the non-inducible or the neuronal nitric oxide synthase, which now increases nitric oxide in another way, in a more sporadic way, which then initiates, mobilizes monoamine release, eventually resulting in your behavior alterations. So let me just go back there. You can see there how the inflammatory process has kind of a two-pathway direction, more of a prolonged redox pathway, and then which is involved in all the redox mechanisms. And then you have one which is a delayed response, which depends on the role of how these redox pathway the monoamines, and they release the effects on behavioral function. So let's have a look at inflammation, the psychiatric illness and treatment. So inflammation plays a significant role in psychiatric illness. That has been known for at least 10 years or maybe more, where there's been an increased knowledge of how inflammation is closely entwined in the genesis of a psychiatric illness. But it's not only in the etiology of that illness, it's also its response to treatment. So for instance, if you look at depression, depression in inflammatory disorders such as lupus erythematosus, Crohn's disease, these disorders are very prone to depression, and these symptoms are improved by immunomodulatory drugs. Also, your anti-interleukin antibodies, such as those mentioned there, are antidepressant in their own right, and this has been shown in a number of studies. And then also more startling is if you look at patients with treatment-resistant depression, they have a high level of circulating interleukin-1, 6, and TNF-alpha. So you can see these patients present with an pro-inflammatory state, but it's not just depression, psychosis as well. So we see that patients with treatment-resistant psychosis have a high level of circulating soluble interleukin-2 receptor. Similarly, they have high levels of interleukin-6, and interferon gamma is associated with poor treatment response in first episode psychosis. So now we can see how the inflammation as part of the disorder also starts compromising treatment response. So how then can you bring the COVID-19 and inflammation into the whole process of the psychiatric illness? Pretty much summarizing what I've said now, you can see that COVID-19, with or without the presence of a chronic or some form of stress, will impact on mitochondrial function. This, if it's a viral infection, is associated with activation of your antiviral signaling. And then you get diverse release of pro and anti-inflammatory cytokines, predominantly pro-inflammatory. And what happens here now is this pro-inflammatory cytokines then activates another key pathway in the brain, or in the whole body, in fact, which regulates. It's a very key, you can almost call it a central station between the immune and the neurological system. This is known as a tryptophan urine pathway. And when you have excessive pro-inflammatory cytokines, you get increased production of quinolinic acid, which is neurotoxic, at the cost of lowering quinurinic acid, which is more neuroprotective. And what do you get? You get increased oxidative stress, decreased neuroprotective ratios, what I mentioned in the earlier slide. And that really leads to those regional brain changes, especially monoamines, and the symptoms, behavioral alterations, which we then see. The question that one can of course ask is then, where does psychotropics act? So when they do address the behavioral alterations, are they in some way also targeting those redox pathways and those neuroprotection pathways and so forth? And that has been a subject of intense research for many, many years. So for instance, if you look at this table, which is, I apologize for being quite busy, it is a direct copy of a picture from the paper in the bottom left there. But what you can see there is that psychiatric drugs have both pro and anti-inflammatory effects. And this can vary according to the redox state, and often the state of neuroprogression of the illness in the patient. So the more advanced or a certain state of the illness, the more disordered redox the patient is finding themselves, and so the cells will differ with regard to how they respond to any redox active agent. And if you see there on the left there, you can see antidepressants, you can see antipsychotics, typical and also atypical drugs, and you can see on the table there, both left and right, they can present with both pro and anti-inflammatory properties. And literature is very, very definite about this. You cannot really predict what you're going to get. And that kind of puts a little bit of a cat amongst the pigeons as to trying to figure out how these drugs will act in a situation such as COVID, where you're having a combined state of inflammation. You can see mood stabilizers as well have the same type of bimodal type of reaction that could be evident. But nonetheless, there is the chance that their anti-inflammatory actions may be very beneficial. And I think, as we heard from Professor Spedding, that's what we're hoping for. And we're hoping that one day we can actually separate the risk or the influence or the bias of the phospholipidosis, which these agents are causing at the moment because of their high lipophilicity, which kind of skews the conclusions a little bit. It's exciting work in any case. The next slide then looks at, just to recap again, on looking against the process of the SARS virus, and now we look at bringing the drug into the picture as well. So for instance, you can see there on the top, you see the COVID with the stress, with or without stress again, impacting the pro-inflammatory cytokines, which then impacts your impaired structural integrity of your neurons. We've mentioned the neurotoxicity. And this then affects the whole functionality of this pathways in the brain, the different brain regions, the ventral striatum, the locus coeruleus, and all their associated neurotransmitters. And how these are changed will determine the kind of psychiatric presentation that the patient is going to present with, whether it's a dopaminergic or glutamate or serotonergic dysfunction. But when you combine it with some sort of stress, and that can be some environmental stress, which is causing the patient to go into depression, or it might be the stress of the COVID infection, you can see how this can cause a major disruption of these pathways. Now you throw the role of the psychotropics in, and now you start seeing, I wonder how this is going to affect the eventual outcome of the illness. And this is where a lot of research still needs to be done. So try and find out exactly where we're going and how effective psychotropics can be in the treatment of the COVID-related neuropsychiatric manifestations. Again, another slide from this paper is just to show that it's perhaps not all doom and gloom. And I think that goes back to the title of this presentation, is that we'd like to, and I think we've seen it from the previous speakers, is to try and entice new research. And I think Africa is in a perfect position to try and jump in and start looking how we can try and develop novel targets for this virus, not only for the general aspects of the illness, as you mentioned earlier on, the different types of drugs and so on, but the neuropsychiatric manifestations specifically. For instance, you can see there that we are now looking at psychiatric effects, inflammatory effects, and antiviral effects. So what we'd like to do is try and identify drugs which have the possibility of targeting those aforementioned targets that are involved in COVID virus infection. So we mentioned things such as your ACE receptors, we mentioned the mitochondria, we mentioned redox systems. These are the things that sort of are hinting as to potential valuable new drug development. So therefore, we can look at antioxidants, and you can see a number that I've mentioned there that are potentially value. You can see there are some plant extracts, and this is only 2 or 3 that I've highlighted. I will mention a bit later on about that. But I know in Africa there's a myriad of these indigenous plants and the indigenous knowledge that we have that we can hopefully try and tap into this to see how we can try and address this illness in a better way. I mentioned the alpha-2 receptor, the angiotensin coenzyme enzyme receptors. There's also the alpha-2 modulators that have been shown to have some benefit that could be useful. The COX-2 inhibitors, because of the effects on inflammation, as with the glucocorticoids. We can look at lithium, which is also has some very important effects on the inflammatory cascades, especially on NF-kappa beta, as you can see over there, which seems to be a key regulating the inflammatory cascade. And then interesting, there's a lot of evidence to show that the melatonin system, especially melatonin 1 and melatonin 2 agonists, such as melatonin itself and the new drug antidepressant called agomelatine, may have particular value in addressing the COVID-related psychopharmacology or psychopathology. Taking it further, there are a lot of exciting information with some of your antibiotics. 2 of them being tetracycline. A little bit later, I refer to rapamycin. These are antibiotics that have been shown to have very powerful neuroprotective and anti-inflammatory properties and have shown some benefit on viral actions as well. I'd like to stay a moment on this one because this is where Professor Spedding and other speakers have mentioned very important dysfunctions in patients with COVID, and that is the mitochondria. What about the role of mitochondrial rejuvenators and modulators? I think methylene blue is one that comes to mind, especially as a drug for potential reinventing itself and reapplication as an old drug into a very new disorder. It is a very powerful, yes, it does have the tricyclic structure of a CNS active drug, so it could have some effects on phospholipidosis and the general membrane effect that we heard in the earlier presentation, but it's also a very powerful modulator of mitochondrial function in its own right. And I think this might have important functions. There are the Oriental Inhibitors such as rapamycin. The NF-kappa beta inhibitors pros are pretty interesting. I don't know if you know that albane and digoxin, which are well-known therapeutic agents, are NF-kappa beta modulators. Maybe there's some value in this. They have shown benefits in viral replication. PD4 and PD5 inhibitors offer some interest, again, because the actions on inflammatory properties. PPAR GABA agonists such as pioglitazone, also a very interesting compound with some potential in that regard. And then you might recall earlier on, I mentioned the importance of the tryptophan kynurenine pathway. And here allopurinol seems to be a very effective modulator of this pathway, which also has a role to play in inflammation. So it has been shown to target inflammation in its treatment. This could be very useful. So what then about herbal medicine? So I mentioned earlier on that that's something that we in Africa can definitely think of. And I know a lot of my colleagues right now, ears are standing upright and see how we can do this, because many of us have spent many, many decades developing our indigenous knowledge field. So we know that one of the things that drives herbal research is the high level of non-response amongst patients with anxiety, mood, and psychotic disorders. So that's, we just know, for instance, depression, around about 55% of patients will respond to the drug. And now COVID-19 is adding to that mystery and that mayhem as well. Maybe we have something that can bolster the current research and develop pipelines which big pharma are finding problems with. So we do know that already pipelines in many of the big drug companies are being sidetracked from the central nervous system research because of the complexity of developing new drugs and taking them through to eventual clinical use. Then what we really need to do is look at new treatment options, not only as monotherapy, and that would be fantastic, but I think in the area of herbal medicines, we should not overlook the importance of adjunctive treatments. And I think here we have is an area that I particularly like to focus on. And that is because many of the drugs we have got today, antidepressants, antipsychotics, are really targeting certain relevant targets. We're engaging with those targets, but they're not developing the full spectrum of receptors and biological markers that should be targeted in a specific illness. And so by broadening our current sphere, either a broad spectrum drug with multiple modes of action, or having a drug which can target multiple receptors, such as those which involve the COVID-19. So the one I'm thinking of, and I'm just going to briefly cover on that, is the closing aspect of my presentation. So we have repurposing traditional medicines. This for COVID-19. What about using traditional medicines for this purpose? So at this conference, we are going to, and the reason why I've selected Sclerotium tortuosum, because it's an African plant. I had a couple of others in mind as well. I wasn't too sure how they would fit the time, but I think it's fine. But I think just for the purpose of just highlighting the point, I'll be focusing on Sclerotium, which is something we'll hear a bit more about in the later presentations at this conference. It's an African plant that comprises two principal alkaloids, the mesembrinol, mesembrinone, and mesembrine. Now, these have all been shown in a number of biologic activities to be very strongly antioxidant, anti-inflammatory. And of course, that is common to many plants, but also it's been shown to have unique actions on the serotonin reuptake transporter, very much like your serotonin reuptake transporters like Prozac and these type of drugs. It's a monooxidase A inhibitor, and very importantly, it's a cyclic AMP-PDE4B inhibitor. For those who don't know, the cyclic this particular PDE is specifically involved in the regulation of cyclic AMP, which is a key second messenger system in many subcellular mechanisms which are targeted by inflammation. So not only inflammation, but also various other psychological and mood-related manifestations. So that aspect that holds a great interest. Both preclinical studies and clinical studies. I'm giving a lecture.
Oh, sorry.
So just lost my space there now. So you have these, the evidence that these multiple modes of action then shows that clinical studies and preclinical studies emphasize that they are very effective antidepressants with anxiolytic and possibly pro-cognitive actions. So these all seem to target, as I've mentioned before, critical processes involved in COVID. So perhaps we're looking at something very useful here, but it's also gone further in the fact that there's very positive preclinical and clinical database to show that this might be very, very useful. And I think this is sort of a take-home message which I'd like to see is that we should really start delving back into our archives of those lost and forgotten medicines. I mentioned methylene blue. There's a number of others, and of course our natural products, which might be that help us to look at this much more specifically. So in conclusion, ladies and gentlemen, is that of course I've tried to highlight the actual risks involved in trying to address neuropsychiatric illness in COVID with psychotropic medicines because of their unknown actions on the inflammatory cascades and how these may positively or negatively influence the patient and the patient's outcome. So one has to then identify the risks when you're dealing with these kind of incidents, consider the trauma, inflammation, and immune dysfunction in your patient, and how and the specific presenting symptoms from COVID, any comorbid psychiatric illness, and what psychotropic medicine you're giving, especially any adjunctive treatments, how that may affect the overall picture. And then look at weigh up the patient's risks regarding, again, their COVID-19 symptoms, or specifically a COVID-19 patient. What is the likelihood of that patient developing a psychiatric illness? Is there a family history of it? Are they in a situation which may precipitate a stress-related illness? And what other multiple drugs are they using, which all eventually could, combine to complicate the response and the long-term prognosis for this particular patient. And I think then for further in the future is that we start monitoring these patients, managing the risks, look at the clinical response. Earlier on, we heard one of the speakers raise a question about the importance of biomarkers. We need to identify suitable biomarkers. Of course, inflammatory markers, as I mentioned earlier on, are very, very important, but maybe there's a unique one that we can identify, and how these can lead to maybe answers to adjusting treatment. And then after you've adjusted treatment, to go back and then look again, monitor biomarkers, clinical response, and so forth. And ultimately, maybe in a couple of years' time, we'll see reports coming out from Africa showing maybe a use of a particular African drug, which has followed a very unique process of development in the COVID-related field, from humble beginnings to something very, very exciting. So thank you, ladies and gentlemen. I really appreciate your time and your attention. I'll just leave you with my disclosures. And yeah, I think I'm open to any possible questions when these arise. Thank you so much.
So Professor Brian, thank you very much for that illustrative, very enriching talk. Now, ladies and gentlemen, the floor is open for questions and discussions regarding the topic that Professor Brian has just presented. So, who's going first? Okay. I can see something coming in from Professor Spedding. So it says, Brian, have a great talk. Fluoxetine also affects glycosphingolipids. I think we should discuss setting up a specific trials in Africa. So that's for you, Brian. Okay. So questions? The floor is open.
Can I?
Oh, Professor Spedding, yes.
Okay. Can I just add to that? I thought that was a brilliant talk, Brian. And very, very important, and we've got many aspects which are similar. I've also run an entire research center on stress and inflammation in the brain, so I know just how important the critical terms are. I thought it was a wonderful presentation, and I think actually that this is so important that we ought to see if we can actually get a working group formed from this Congress in order to be able to prioritize trials in Africa, because I think that the fact that the vaccination is late means that if we have a second round of looking at drugs in very specific ways and combinations of drugs, then that would be really interesting. But the problem is, I just wanted to point out a problem that I've had. If you've got a cheap generic drug, it's almost impossible to get finance from companies, etc., because they don't see the business model. But the business model, when there's so many people dying and so much loss of time, is crazy. So governments are the way forward, and also having been able to set up intelligent clinical trials. And you've got a wonderful set of compounds there. And I would add ambroxol, but I would also add possibly, as you said, melatonin to take at night, and have a combination, because we've worked on the anti-inflammatory effects of melatonin at night. It's quite amazing. And I think there are ways forward whereby you could lead a specific action group, perhaps initially in South Africa, but possibly elsewhere, linking it with DNDi perhaps, for getting those trials in, because I'm trying to do that. And I think it's a matter of having a group which can then provide the right clinical trial design and light clinical design and the right choice of drugs.
No, thank you. Thank you, Michael. Thank you for the comment. It's fantastic. And I'm glad to hear there are others that share the excitement. Yes, I think I agree. We should get together and chat and see how we can take this to the next level. Fantastic. And yeah, I think I've learned a lot from your presentation as well, because in fact, I would have wanted to show, slip in some of your slides to try, it actually brings a lot of clarity to things, and I think that's important. We don't want to get excited about something which still is not, thought out and, walked through in the best way possible. But I think there's a lot of hope there. There's a lot of compounds that I think that are useful to study and investigate. So I don't know how you feel about the methylene blue idea, but that's something which I'm particularly interested in. And that's why I kind of blew it up a little bit, because in lieu of your presentation.
Okay, well, I think you might enjoy my pre-recorded presentation on Friday on the basis of CNS effects of glucosyl ceramidases and glycosphingolipids, which are then very similar indeed to the effects of infection by SARS-CoV-2. So put that two together, and you've then got a real reason for being able to get governmental testing, because it's the only way forward. I don't believe that big pharma is going to do it. I've spoken to 8 big pharma to get just the drug testing of Ambroxol, which I've got excellent validation for, but the business model to them doesn't work. So it's got to be governments. That's why the Indian government is testing.
Okay. No, I'll definitely. I'll earmark that for Friday. Thank you.
Thank you. Brian, there's a question for you from Dr. Sylvia Opanga that is on the chart there. It says, what is the existing data on COVID neuropsychiatric and neurodevelopmental effects in the pediatric population? And any drugs that can be repurposed for this group?
Wow. Again, that's a great question. No, so I can't offer any solid answers on that. What we've been doing last is reviewing sort of generally, the adult population to see, as a starter point, and that's where this presentation was birthed, is from that point of view. So from children, nope. Of course, many of those medicines can be considered for that environment as well, but I wouldn't want to put my head on a block or stick my neck out, as it were, to don't say this or that. But it eventually boils down to, rational thinking of how the drugs work, a rational understanding of the underlying pathology of the COVID in the brain, the different brain regions, and how these could best be responding at certain times of development. For instance, we know that children do not respond to SSRIs. That might have something to consider in the under 12s. So the serotonergic system hasn't developed at that point in the neurodevelopmental cycle. So that might be something worthwhile. And then, of course, the associated pathways involved with that. So this is like the kynurenine pathway, which are highlighted, connects in adulthood with a serotonergic pathway. So that might also be less functional in the early years. So I'm just thinking off the top of my head, but it definitely needs a bit of deeper thought and understanding of age-related changes of the brain, and how, and of course, how the immune system manages the infection in the first place. We know that probably differs between children and adults.
Thank you very much. So I think now we'll stop there and move on to the next one. Our next presenter is going to be Beshni Pile Fuentes Lorente. He's going to be talking to us about poisoning exposure of ivermectin used for COVID-19 repurpose to the Poisons Information Helpline of Western Cape. Beshni, if you're there, please take over, and you have 15 minutes.
Sure. Thank you, Prof. Limo. Hi, I'm Veshni Pillay-Fuentes Lorente from the Division of Clinical Pharmacology at Stellenbosch University in the beautiful city of Cape Town, South Africa. Now I'm going to take you through one of our studies. So I'm just going to share my screen. Just give me a moment, and if I could just get a signal that you can see my screen.
Yes, we can see it very clearly.
Great, thank you very much. So I'm going to take you through the poisoning exposures of ivermectin used for COVID-19 reported to the Poisons Information Helpline of the Western Cape. And a brief introduction is that in June 2020, ivermectin was reported to be effective against SARS-CoV-2, and this was predominantly seen in vitro studies. However, this had caused a whole lot of clinical trials which had then followed, supporting the use of ivermectin for COVID-19. However, of note, these studies had quite important limitations. Irrespective, ivermectin did receive quite wide global public interest, and this led to irrational use then of ivermectin for COVID-19. In South Africa, the South African Health Products Regulatory Authority, also known as SAPRA, has not registered ivermectin for COVID-19, or in general, ivermectin has not been registered for human use, and we have mostly veterinary substances available. However, ivermectin in terms of topical ointments, etc., can be made available via Section 21, and there was some media release that it's only allowed to be used in COVID-19 through clinical trials in South Africa. So a bit about the Poisons Information Helpline of the Western Cape. We are situated in South Africa in a province that's all the down western side of Africa and clearly known as the Western Cape. And the PIHWC constitutes two different poison centers, Tygerberg Hospital Poison Information Center and Red Cross War Memorial Children's Hospital Poison Information Center. So the aim of our study was to describe the cases of exposures of ivermectin, which was used for prevention or management of COVID-19, which was then reported to the PIHWC. The objectives of our study was to describe the cases of ivermectin poisoning exposures after the first publication, which was June 2020, and we regarded this as period 1. And then to also describe the cases of ivermectin poisoning exposures prior to the first publication of ivermectin for COVID-19 use, and we regarded that as period 2. We then compared a number of cases between periods 1 and period 2, and we went further on to describe the clinical presentation a bit more. So our methodology was as follows. Period 1 was taken from the 1st of July 2020 to the 31st of July 2021, and period 2 was from the 1st of July 2019 to the 30th of June 2020. So we looked at all ivermectin calls received within the PIHWC between these two periods. So the PIHWC uses a Telelog database, which is basically a data collection system to capture all calls made to the PIHWC. And we then did a retrospective review of the cases between both periods. Each case was reviewed by 2 study investigators, and the study received ethical approval. In terms of statistical analysis, we created an electronic case report form on a REDCap database, and we analyzed descriptive statistics using GraphPad Prism version 9, and we further described the data using percentages and frequencies for binary data or categorical data, and continuous data was reported as medians and interquartile ranges, or means and standard deviations if they showed a normal distribution. In total, we screened 52 cases over the 2 periods. We excluded 5 cases, one because the caller had called in purely for information on ivermectin, and 4 of the calls were repeat calls. So these 5 cases were excluded. So included in our analysis was 47 cases, of which 44 cases was during period 1, and that is post publication of the first ivermectin in vitro study, and period 2 was prior to the publication, which we had only seen 3 cases. In terms of baseline characteristics, majority of our callers were medical personnel and to a lesser extent public. Most of our calls came from private facilities, about 70.4% in period 1. And the circumstances of poisoning exposures within period 1 was predominantly COVID related, so 81.8%, roughly 82%. Figure 2 illustrates the common presentations in terms of organ systems, which was reported to us. And from this, you can see the most common organ system was the central nervous system of around 44%. And most of these symptoms was ataxia, visual disturbances, and dizziness, a bit of nystagmus as well. 2 of our patients were actually comatose and quite severe cases. And then second was the gastrointestinal tract, and this was more the nausea, vomiting cases. Figure 3 is basically just showing a breakdown of the type of preparations. And I think it's important to note here that many of the callers actually could not tell us much about the information, the drug formulations or the doses that they had taken. So majority were unknown preparations, so about 61%. And that was followed by a larger, a good amount of patients using the veterinary preparations for COVID-related management. And 5.6% was actually human preparations, but we know they were not registered in South Africa. So quite interesting to see where these patients actually got access to this from. So from this, what we could tell is that the ivermectin toxicity we were seeing during the COVID pandemic reported to the Poisons Information Center of the Western Cape was due to the use of formulations with unknown ivermectin concentrations or other constituents. These were generally higher doses of ivermectin, and we know that the clinical trials that have been released had varying degrees and doses which were being used. So there were no standard doses, and generally patients were exposed to quite high doses of ivermectin. Repeated doses within short intervals as well. And then, of course, the use of animal formulations. Generally, the route of administration was different to that specified within the package inserts. From this, what we can tell is that there should be more stringent processes which have to be implemented in order to control this a bit better. The limitations of our studies was that not all ivermectin exposures in South Africa were reported to the Poison Information Helpline. We do get calls from different provinces, but not all calls or not all toxic cases that get to hospitals are consulted with us. Generally, it's the cases where doctors are not quite sure with management of ivermectin toxicity and need further advice, but we may have missed some of those cases that had just the normal nausea, vomiting with no other severe neurological symptoms as well. And then, of course, the exact formulation and dose of the ivermectin ingested was not always known. And this is purely because the patients that had presented to the clinicians could not really give them more information around the ivermectin. So in conclusion, ivermectin is being used to prevent and manage COVID-19 in the absence of robust evidence, dosing recommendations, or appropriate formulations. Consequently, we've seen that ivermectin related poisoning exposure calls reported to the PIHWC increased by approximately 14-fold after the first publication. And then predominantly, this is because of ivermectin being taken for COVID-19 prevention or management. Just a list of references, and we would like to acknowledge the staff of the PIHWC for their hard work and dedication. Thank you.
So thank you very much, ladies and gentlemen. It happens that Veshni had 2 talks, and these 2 talks were given back to back. So I will allow her to present the second talk, and then we can take all the questions at the end. So if you have questions regarding what she's just presented now, please write them somewhere, and then you can ask when we have consolidated them. But I would like to ask Vaishni to move on and give her second presentation. Please go ahead.
Thank you. Okay, so second study we've actually done was hospitalized COVID-19 patients treated with low molecular heparin and antiplatelet therapy. We'd seen an increased thrombosis, but no increase in bleeding risk. So a bit of introduction and background to this. There has been an increased incidence of thromboembolic events in COVID-19 patients, and this is despite the use of low molecular weight heparins. There has been numerous autopsies of COVID-19 patients and previous clinical trials that have demonstrated a phenomenon known now as COVID-associated coagulopathy. So in our setting, low molecular weight heparins, which is most commonly used, is enoxaparin, and a bit behind the mechanism of action. So enoxaparin binds to and potentiates antithrombin 3. This complex binds and irreversibly inactivates clotting factor 10A, and this in turn prevents progression of the clotting cascade and thrombin formation, hence its use in COVID-19 and actually promising use, where there's studies now evaluating higher doses to see if this would be more effective in treating COVID-associated coagulopathy. So there's been numerous studies as well that have reported various venous and arterial events in COVID-19 patients. And this is stroke, myocardial infarctions, acute limb ischemias, etc. In addition, platelet activation has also been described in what we know as the thromboinflammation model, but this is quite complex and not completely understood. There's been a lot of theories around this, a lot of hypotheses, but the thromboinflammation model is quite complex. And what we do know from it is that it does cause platelet hyperactivity and therefore increased platelet activation. So antiplatelet therapy was then suggested to be beneficial. However, the robust evidence regarding the effectiveness of combination therapy of low molecular weight heparin therapy as well as antiplatelet therapy is lacking. There were common autopsy findings which showed diffuse lung hemorrhage and hemorrhagic inflammation. And because of these findings as well, if there was a combination therapy being used with low molecular weight heparin and antiplatelet therapy, there may be a bleeding risk with this additional antiplatelet therapy. So it may lead to increased bleeding with increasing doses as well with dual or triple antiplatelet therapy. So from this, we actually aimed to describe the bleeding and thrombosis outcomes in patients with COVID-19 admitted to Tygerberg Hospital in Cape Town, South Africa, on low molecular weight heparin therapy, and then looking at low molecular weight heparin therapy in combination with antiplatelet therapy or without antiplatelet therapy. The objectives of our study was to describe the proportion of patients with thrombosis and bleeding outcomes, to describe the proportion of COVID-19 patients with antiplatelet exposure prior to admission and or during admission, and to describe the dosing practices of low molecular weight heparin prescribed to COVID-19 patients. Our methodology was as follows. We did a retrospective file review of eligible patients, and we did this during the first wave in South Africa, and that was from the 25th of March 2020 to the 31st of July 2020. The 25th of March was when we had detected or admitted our first case at Tygerberg Hospital. Various hospital databases were used to collect clinical information, and this was from history to the clinical examination and clinical findings, laboratory findings, as well as prescribing practices. And the study received ethical approval from the appropriate committees. The eligibility criteria was patients greater than or equal to 18 years of age, those that had a nasopharyngeal swab confirming COVID-19, predominantly via RT-PCR, and those who were prescribed low molecular weight heparin in prophylactic or therapeutic doses. We excluded studies if they were missing or incomplete patient records. We identified antiplatelet exposures by firstly looking at databases which showed that patients had been dispensed antiplatelets 1 month prior to admission, or if patients were admitted and administered antiplatelets during hospitalization. We identified thrombosis and bleeding in the retrospective file review if there was a high clinical suspicion as per the clinical notes, or if there was confirmed thrombosis or bleeding by radiological imaging. In terms of the statistical analysis, we looked at the exposure and outcomes and described them as odds ratios with a 95% confidence interval using the chi-square or logistic regression. We then did multivariable logistic regression as well, and if predictors were deemed statistically and clinically significant, these were further analyzed. We analyzed our baseline characteristics on GraphPad Prism, and we used a statistical significance set at a p-value of less than 0.05. So we screened 998 patients retrospectively. We excluded 190, and for the various reasons, as you can see. And we then ended up with 808 cases, which were then included in the analysis. Of the 629 patients were analyzed who were on low molecular weight heparin therapy without antiplatelet exposures, and 179 patients were on low molecular weight heparin therapy with antiplatelet exposures. Of note, when looking at the baseline characteristics, the antiplatelet group actually had more comorbidities, had higher oxygen requirements, greater ICU admissions, and actually had a higher mortality rate. From figure 2, we can actually look at one of our primary outcomes, which was looking at bleeding and bleeding outcomes in patients with low molecular weight heparin therapy and patients with or without antiplatelet therapy in addition. From this, we can see that the bleeding outcomes was not statistically different between patients on the combination therapy or on low molecular weight heparin therapy alone. Figure 3 shows our thrombosis outcomes. And from this, we can actually see that the potential of developing thrombosis, or the odds of developing thrombosis, was about 4.8 times higher if patients were on low molecular weight heparin therapy and antiplatelet therapy, as opposed to low molecular weight heparin therapy alone. We further analyzed this in terms of the prescribing tendencies, and we've seen when looking at antiplatelet and anticoagulation therapy in patients with bleeding versus no bleeding, that patients who had bled actually had a greater tendency of being prescribed therapeutic doses of low molecular weight heparin and antiplatelet therapy. When we looked at the thrombosis outcomes, we saw that most of the patients who had developed thrombosis were on either therapeutic doses of low molecular weight heparin therapy or was on prophylactic low molecular weight heparin therapy plus antiplatelet therapy. So from this, what we could see was that COVID-19 patients on low molecular weight heparin and antiplatelets had similar bleeding outcomes compared to patients without antiplatelet exposures. However, conversely, we did see a higher thrombosis outcomes in patients on low molecular weight heparin therapy and antiplatelet therapy. From this, it could be that the bleeding risk could be offset by the increased preponderance of thromboembolic events in COVID-19 patients compared to the bleeding alone. And the paradoxical observation that we've seen could be explained by a few things. Firstly, the initiation of antiplatelet therapy in more severe disease. So when we looked at our baseline characteristics a bit more intensely, patients that were on antiplatelet therapy actually presented requiring greater or higher oxygen requirements, so they came in with more severe disease. They also had more comorbidities, which was contributing as risk factors for developing severe COVID-19 disease. What we also noticed was that the timing of antiplatelet therapy in our cohort was predominantly during hospitalization, and not many patients with severe disease was actually prescribed antiplatelet therapy prior to hospitalization. So timing could have been an important factor, where the timing of antiplatelet administration was actually quite later in the disease course as opposed to prior to developing COVID-19. And then, of course, questionable was the dose of aspirin, which was the most common antiplatelet used in our setting. And it may have been too low for an antithrombotic effect. And we couldn't assess this further because not all patients had routine weight measurements done. And this is for obvious COVID-19 precautions, as well as the severely ill patients who were unable to stand on a scale. And we actually did not have sophisticated beds in ICU to measure weight of these patients as well. Some of the limitations of our study was that causality could not be assessed. And this is purely because of the study design and the retrospective nature of the study. There was a higher antiplatelet use in patients with thrombosis. This could have been a confounding by indication. And then, of course, the routine weight measurements was not done, and not all patients with clinical evidence of COVID-19 associated coagulopathy at diagnostic radiological imaging. So, for instance, patients with DDTs were diagnosed predominantly on laboratory findings as well as clinical presentation. So in conclusion, the bleeding risk in COVID-19 patients is not significantly higher in patients on low molecular weight heparin therapy and antiplatelet therapy when compared to low molecular weight heparin therapy alone. There's a potentially higher risk of thrombosis in patients on low molecular weight heparin therapy and antiplatelet therapy, but this likely reflects confounding by indication in our study. Antiplatelets should not be prescribed outside its standard indications in COVID-19 patients, as our study could actually not assess causality, and we couldn't come to a definitive conclusion. What we could say is that it shouldn't be used outside its standard indications in COVID-19 patients, and further randomized clinical trials are needed to allow for further assessment of the role of antiplatelet therapy in COVID-19. So a list of reference and our acknowledgements. Thank you.
Very well. Thank you very much, Vaishni, for those two excellent talks on ivermectin and on these antithrombotic drugs. So I would like to open up the floor now for questions. We have a few minutes. We can ask Vaishni questions before we move into our poster session. So the floor is open for anybody who has questions for Vaishni. Professor Walubo, I can see your hand up.
Thank you. Thank you very much. Thank you, Vanish, for your presentation. In fact, both very good. Excellent. I just wanted to, I think, to add a comment, or you can maybe give me something about it, that given that ivermectin is not approved in South Africa yet for human use, in fact, for COVID, let's be specific, is that the doctors are, as you say, they are reporting and not wanting to give you a lot of information, especially on the dosage forms. But at the same time, I also take it that the reporting being given as anything they are saying they are seeing is adverse effect. Isn't it also could be a mistake? Because even if you are saying prevention or use for treatment, those symptoms are not due, I mean, those features are not you cannot differentiate them from COVID. Central nervous system, given even the previous lecture we have had, you find that still, and especially given the different doses of ivermectin, and the fact that ivermectin, even if it's not used in South Africa, it is widely used in other countries. And those things are not such in a small population, a few people, and it comes out like a very toxic drug. So I'm looking at it, isn't also overreaction that everything being reported is a side effect of ivermectin. In fact, one time even I know a patient who also, we run a poison information center, who after 2 months of treatment for 3 days with ivermectin, standard dose, was saying that the scale skin on his leg was told by a doctor that it was due to ivermectin. Until we said, no, try this vitamin A Vaseline, and it worked. So that is one of my concerns there, that probably overreaction. So we need to be a bit more careful to ascribe all that to ivermectin side effects. From the second lecture, I don't know whether they reported anything about measuring heparin antibodies, platelet antibodies in those patients, because we know that what low molecular weight heparin still can also induce heparin-induced thrombocytopenia, leading to those similar abnormalities. But I didn't see them doing any investigation, because heparin, those whether low molecular weight, still they can also induce a similar problem, even if it is not clinically very clear to come out with a lot of things, but COVID can just worsen it. So there was no report of heparin-induced antibodies. Thank you.
So please respond to those two before we ask you another.
Thank you, Prof. Olubu. Quite interesting comments and good questions. So the first about ivermectin. So the signs or the signs and symptoms that was reported to us at the PIHWC was actually a common adverse effects that you see with ivermectin. So this is just talking outside the setting of COVID-19. We do see a lot of dizziness, visual disturbances in overdoses, etc. And the other aspect of kind of figuring out if this really is ivermectin or due to other disease causes was analyzing the history a bit further. So these were actually witness doses, and the presentation had started after ingesting the dose within a certain time frame. So in terms of that, we could actually say this was most likely ivermectin related. And in majority of the cases, there was no callback to say they were having issues with it. But with that being said, if there was a case discussed with where it could be conflicting with COVID-19 symptoms, we often advise to do a COVID-19 testing. In terms of the second question around HIT, so heparin-induced thrombocytopenia, absolutely agree with you that it can be seen with low molecular weight heparin use as well. In our setting, it was not done routinely. It's not baseline tests. It's only done if highly suspected based on diagnostic criteria and using the basically evaluating for the 4 aspects. So this was not routinely done. And there has been studies which actually showed that higher doses of low molecular weight heparin actually had higher thrombosis outcomes as well. And how much of HIT this contributes to, we don't really understand fully at this point, but hopefully future studies will help us understand this a bit better. I think if we look at further studies, it will always be good to do a pre-probability scoring when starting low molecular weight heparin therapy and actively looking for it going forward. That will be the best way to analyze it.
Okay, thank you very much, Veshni. There is a question here from Dr. Sylvia Opanga on the chat. It says, is it possible that some of the patients had prior diagnosed clotting disorders or a higher risk of clotting from the other causes other than COVID-19? That's number one. Number two, she asks, were you able to get this information from the review of your databases?
Yes, thank you for that question. So we could, one of the databases used within our hospital is a provincial database system where all medical records of every visit gets uploaded onto the system. So we actually have quite a good track record of all the patient's admissions, and we basically can follow up the patient's entire medical history if within the province. So yes, this is something we would have picked up if they were diagnosed prior with clotting disorders, and we would have been able to see this information from our databases.
Okay, is there anybody else with one more question? We'll allow one more question. Okay, if there's no more questions, I think we've come to the time when we're supposed to go into the poster session. I just want to give some guidance. Before I do that, there's a question. Actually, Vishni, I think this is the last one, I think. It's from Fuad Bashir. It says, Vishni, in your study on low molecular weight heparin and antiplatelet therapy on COVID patients, did you indicate other parameters like INR to conclude your findings?
Yes, thank you very much for that question. So we did, and we analyzed this as baseline characteristics as well. Sorry, and progressively. So some of the laboratory parameters which we analyzed were the INR D dimers. Sorry, just give me a moment. All right, back. So some of the parameters we analyzed were the INR, the D dimers. We looked at C-reactive proteins as well. So we did analyze this in totality at baseline. So with INR, our baseline between the two cohorts were kind of stable, more or less the same, platelets as well as the D dimers. And then, of course, the higher D dimers was seen in our antiplatelet population, or antiplatelet exposure population. But definitely we did include this in our findings.
Okay, so thank you very much. Now, a comment about the poster session. I've just seen a flashing message on the screen, which is a link to where the poster sessions are. They are now open. I think people can go into those poster sessions and follow the instructions we were given earlier on to be able to actually interact with them again. So I really want to thank you for that. Again, I can see they have actually sent the link. It is on the right, it's on the chat box there. The poster gallery linkage is http://knh.unconferences.knh.or.ke. So please, you can move in there and interact with those posters. I don't know whether Professor Gwantai is here. Professor Gwantai, if you are there and you want to make some final remarks about this, it'll be good. If not, I will make those final remarks and allow people to go to the poster sessions. Are you there, Prof?
Yes, Professor Bulimo, I'm here.
Yes. Do you have any final words you want to say before we allow them to go to the posters? Or even
I can only actually thank them for the commitment to the Congress and the active participation. It has been a wonderful day today. I believe you all probably have the same feeling. And now we move to, as Professor Bulimo said, we move to the poster session, have a taste of it, and then probably we shall give a feedback at the end of the day. And if there are any areas of improvement, let us know. You can post them on the chat so that we can improve when we meet again tomorrow. So Professor Mulimo, I think those are just my few comments. I have enjoyed every bit of the presentation. I got disconnected briefly because of some power blackouts, I think for 5 or so minutes. But most of the proceedings are followed for the day. And I think I'm impressed by the quality of the presentations and the commitment of the speakers. Thank you.
Thank you very much, Professor Gontai. It could not be said better than that. So I leave people now to exit from this room into the poster session. And thank you very much. We'll meet tomorrow at 11.
Professor Bulimo, can we hear a comment from one of the participants? Roland, can you tell us if you have benefited at all from the presentations?
Okay. Roland, are you there? I can see you, but you're muted. Okay.
There we go, Prof. Good afternoon. I'm here.
Thank you. Yeah, go ahead.
Thank you, Prof. No, it was a very good session. I also unfortunately joined a little bit late. I was in the clinic earlier today, but it was a fantastic bringing together of the preclinical and clinical sciences as it relates to COVID-19. And I believe that it's this type of research and insights that will bring us further. Obviously, there's a big push in vaccinology, but there will still always be a place for acute treatment in those who cannot have ready access to vaccines, who cannot be fully vaccinated, or those in whom the vaccines are not tolerated or contraindicated. So I believe that it's a place and a forum like this where ideas and future trials can be put together to take healthcare in COVID-19 forward.
Thank you. Thank you very much for that comment. Maybe another comment from Blake Green. I'm just picking participants at random just to hear their sentiments. Blake Green.
Blake, are you there?
If Blake is not there, then can we hear from Elsibieta or Sushi?
Who?
She's called Elsibieta or Sushi.
Yes.
Oh, Osuk. Elsibieta.
Osuk, yes.
Yes, good afternoon, colleagues. Yes. Yes, it was wonderful presentations, especially with neurological involvement of COVID is really something exciting. Sorry, what was your questions? Because I was actually moving to the other poster session.
No, just a comment about it.
Just a comment, yes. Perhaps I could, while I'm online now, I could give a comment to the Veshni presentation, very good presentation, but I would be very careful to draw such conclusions that both heparins, low molecular plus antiplatelet can increase thrombosis. I'm not sure, I'm not sure if it was compared the same to the patients on COVID, severe COVID without all these drugs, because we must be careful to draw such conclusion, and obviously more data is needed for that. But otherwise, I think wonderful Congress. I'm excited to be now in a virtual world, because we are moving from one room to another, from one session to another, virtually actually. So it's really something new which is happening due to COVID, and we must get used to all that. But otherwise, great presentations. Thank you so much, colleagues.
Thank you. Prof. Gontai, is there somebody you want, or we can now move? Hello.
I think we are right now. We are okay now.
Okay, so everybody, we can now move to the poster session. Thank you very much. See you tomorrow. Bye-bye.
And I think the link is active. The way it is on the screen, it's active. One can actually click on it and move to the session.
Where is it on the screen?
I can see it is on, yeah, okay. It is on the WhatsApp. I mean, not on the, what do they call it?
On the chat.
Chat box, yes.
Okay,
yes.
thank you. You can just click there.